and gentlemen, the first topic in technology is hot lamination on color-coated lines, and we have with us Mr. Clifton, Tuscano Manager, Business Development, Thermovision Technologies, an engineer, an MBA from SPJ in Management. Thermovision Technologies specializes in thermal solutions for continuous metal coating lines and color coating lines. Can we please have a round of applause to invite him on the dais? A very warm welcome to you.
Hello, I'm audible? Yeah, thanks. So good afternoon, friends. And I should thank one and all for waiting for so long for my session. And I have few friends over here and customers as well as colleagues who are asking me constantly, when is your presentation? And we'll be waiting and encouraging you for this presentation. I said thank you very much because the day has been very long and you all have been holding your seats very tightly for very, very long. So to cut it short, I'll not touch most of my company products or something like that, but I'll focus my presentation mostly on the technological part of it. So last time, when I was on a very similar conference in Delhi for GCP '08, we presented a case on upgrading your existing furnaces. So you may be having your existing process lines where you have a certain kind of productions. And we talked at length about how you could actually improve your existing process lines or furnaces for producing higher quality value-added conventional high-strength steels, as well as how you could increase the thicknesses and speeds on these lines. So that was at length which we discussed during a very similar session that Tambeji had organized in Delhi. And on that discussion, when I ended my presentation during that talk, I specifically mentioned that during my next upcoming discussion, where I mentioned to Ajay Tambe that we'll be presenting again the case in my next presentation, and I mentioned to him that we will be talking on color coating ovens, RTOs, incinerators, and technologies which are associated in the CCL field. But if you all know, I mean, most of you may be already working on CCLs, right? You may already have an oven or incinerator or an RTO as one of your process. But something which we really lack today in country, or something which we do not produce. We produce a lot of commercial steel, coated PPGI. We produce a lot of silicon modified or polyester paint steel. But something which as a country or as a manufacturing country we lack is VCM. So most of the VCM is what? VCM is vinyl coated metal. Not most of, but all of this metal is today imported in the country. So as a consortium of a technology provider like us and many who are over here, and manufacturers who are already over here, it should be we should all strive to have this VCM in India. So we did a case study with one of our customers and one of our partners from Korea, LHK, about the VCM process and how you can actually implement a VCM on your existing processing line, like CCL. So what is VCM? VCM is a vinyl coated metal. VCM has a tremendous application in white goods. So today if you see your fridge panels or if your washing machine or any of your consumer products, they look very, very bright, right? They have a finish as good as stainless steel, but they are all steel, which is carbon steel, GIGL coated, and then they have a film of vinyl, which is PET or PVC. So we, as a country, we are the consumers of VCM. We are the consumers of consumer goods. Then why not we should produce VCM in India? So that actually brought us to this topic today. So we have a lot of domestic consumption for VCM products in India. Majorly, as I mentioned to you, it is white goods application. So when you go to VCM, there are three types. Predominantly, one is PVC, is polyvinyl chloride. Second is PET, is polyethylene terephthalate. And the third is the combination of both, that is PVC and PET. Normally, if you want to apply PVC on your coated sheet, when I say coated sheet, it is a base metal which is like GI or GL, which you may use for your color coating process. PVC is comparatively easier to apply. In most of the cases, the thickness is about 120 to 150, and it does not require any kind of heating in order to apply the film on the metal sheet. But the moment you move to PET things become little complex, because PET is very, very thin. If you compare the thickness of PVC to PET, it is maybe 1/4 or 1/3. It is like that. Second thing, when you want to apply PET film on your base metal, you need to also do some kind of heating on the film. And the cooling technology which are required for treating the PET film apply metal also varies. So you need to air cool it, also you need to water cool it. And the third type of film which exists is the combination of both. Now, PVC, if you see environmental wise, is not very much preferred. So most of the applications are now shifting towards PET. And PET is also more durable as well as more agile. It has more rigidity. If you see your existing color coating line, it is pretty standard, right? You have an entry section, followed by entry section, you will have a cleaning section, then you have a chem coating section, your prime coater, finish oven. This system remains same when you want to implement a hot laminating system on your existing color coating line, or even if you are in one of the discussions where you have a plan of investment of a color coating line of higher speed, these sections would remain same. The changes would happen in the finish coater, the finish oven, and then comes the hot laminator. The finish coater is the place where you will apply glue on the top surface of the sheet. Once you apply glue on the top surface of the sheet at the finish coater, the curing of the glue will happen in the oven. That's the place where curing happens. And once the curing happens, you have the film, you have the sheet with the glue, and from one side you get a film, and the both are applied together in a hot laminator. So parallelly, as you have the entry section for the sheet, you will also have separate section for the film. So on the film side, you will have one unwinder, you will have film accumulator. In some film, you will need some kind of heating. As I mentioned to you previously, for manufacturing PET or PET plus PVC, you need some kind of heating. So that heating technology will be available before the hot laminating system. Once the film is treated, then the sheet as well as film, they will come together in a hot laminator, and then the further cooling section will come. This is how your existing color coating line would look if you install a hot laminating system to it. Whatever I said, it feels pretty straightforward, because what is the challenge, right? You just have to install one equipment on your existing color coating line, and we are just ready to manufacture the VCM product. If that would have been the case, I think India would have been producing it pretty long, because we are manufacturing most of the value-added steels as well as color-coated steel in India. But that is not the case. When you really have a case study for VCM, you understand what are the criticalities that are involved for manufacturing or processing VCM products. The first thing is line cleanliness. I may sound very basic or fundamental or rudimentary when I say that the line needs to be very clean. But you go to, from commercial production, the moment you move to auto grade, your line speed reduces. Let's say you are manufacturing commercial production at 150 mpm. The moment you shift to auto appliances or white good appliances, your speed would be 80 mpm, let's say. But the moment you go to VCM production, your speed is not more than 60 mpm, because that's the maximum speed at which you can have the film and metal together. Having said that, most of these lines are designed for 150 or 120 or 100 mpm commercial productions. So we don't take into considerations the cleanliness that is required for producing VCM. Imagine, when I say VCM, imagine you have a phone, right? When you buy a new phone, what first thing most of us would do? they'll do two things. The first is they'll apply the back cover for the protection, and the second is they'll apply the front cover, right? Some glass or lamination or something like that. Now you just imagine the moment you went to one of the stores to apply a film on your mobile front screen. If there is even a single dust particle, you see a bubble. Then the person who is applying that film, he'll try to remove it physically. But do you think you can do it in a process which is running at 160 mpm? Impossible. So the first thing is, whatever commercial production lines that we have for CCL, they need to be very, very clean. When I say very, very clean, what do we need to do if we have a CCL, and how can we make our line clean? First thing is we need to isolate it in some manner or the other. For example, you need to cover the line. You could have seen some lines, maybe out of India, whenever you have gone, or to some of your customers, where the line may be covered through acrylic sheets or some kind of air washers or something like that. The main reason for that is to avoid dust intrusion. Even if you have a minuscule of dust on your coater or in your ovens or on your hot laminating areas, you are bound to get a defect. So that's something which is pretty challenging for us to implement on a general commercial processing line. The second thing is, when we design a commercial line, we design it for, let's say, 100 mpm or 120 mpm. So we take into consideration the market demand. The moment we shift to VCM production, because we will be doing it for the first time, we will not increase process speed more than 20 or 30. The moment you say that your process speed is less than 20 or 30, आपका तो 3-4 दिन का production निकल गया. So you have your pressures. So that is the reason the moment you try to get into the motion, you are not able to get it. Because your original line is designed at 150 mpm, and now you are running line at 30 mpm just to have the production process. You are not able to set it. So that is the reason you need to give this specific amount of time on your existing color coating line for VCM production. Third is the line availability. As I mentioned to you, VCM may not be your priority, right? Because when you want to produce, you want results just like that. But that doesn't come with VCM. And if you are not able to produce the quality product at the first instance, your availability is wasted, your hours are gone, and your yield is reduced. So that reduces your confidence, and you are not able to produce it. So although the cleanliness aspect plays very important role, manufacturing VCM or vinyl coated metal on an existing process line itself is a process. So there are two ways to do it. Either we go through an existing process line and go through the whole process, or we take a dedicated approach. So when I say dedicated approach, what do you mean? Why not have a separate VCM line? Why not have a separate VCM line which is targeted at around, let's say, 40 to 60 mpm? It's not a very big line, it's not a very complex line. The movement we try to add many complexities to the existing line, we become jack of all trades and master of none. That is what we try to do. But the moment you try to have a dedicated line for producing VCM with a dedicated team, with a dedicated facility which is comparatively cleaner, which has the proper planning of vehicle coming inside as well as outside, which has dust control, everything changes. So the entry section remains same, the cleaning section remains same. You need not have two ovens, because predominantly I am assuming you will not be running a regular commercial production on this line. You will be just producing your VCM. You can still have just one oven. You have one coater, you have one oven. So the function of the coater will be to apply the glue on the strip. The function of the oven will be to cure the glue. And once you cure the glue, it comes out of the oven, and then you have hot laminating system. Now, it was a pretty big picture. I couldn't expand it more. So what I've done is I have just shown the area of lamination. So your entry section remains same, Cleaning section remains same. Coating section remains same. In place of your top coat, you will be applying a glue. The bottom coat would remain as is. Once you apply the glue will come out from the oven section, this portion. It will be cured. This is your film area. Your film will be here. So as it's a continuous process, the film will be continuously coming from this side. This is the small film accumulator because you will be running this line, I'm assuming, continuously at 40 to 60 mpm. So you need to have a very small accumulator arrangement for the film to feed it continuously to the strip that is coming continuously. And then this is the heating unit. As I mentioned to you previously, if you recollect, for PVC you don't need any kind of heating. But the movement, you move to PET kind of films to be applied on the steel strip, you need heating. So the rolls in this area are preheated, so they will have some kind of heating arrangements, either through steam or through oil or through maybe inductive heaters. So different technologies are available. And once this preheated or a film will be guided through this roll arrangement, this is the laminator area where you are stripped from the oven and the film from the top would merge and then it will go ahead. This is the cleaning section, this is the cooling section. It also needs special attention because as you try to coat the metal surface with different kinds of film, the different films require different cooling technologies. So some film you will just need water cooling, but for some film you will need water cooling as well as air cooling and water cooling again. So different films like PVC, PET and a combination of PET plus PVC will need different kind of heating technologies. I tried to manage to show to you some photographs for more understanding of how and why a dedicated approach would be more suitable in case if we are trying to have VCM production for the first time. If you see this area, you see here, this is the ventilation system. The complete area is ventilated. This is the unwinder and this is the roll heating unit. You see this heating units. So this is for providing a heating system to the roll through which the film would come. This is the hot laminator area. Again, the hot laminator area will also have a ventilation system. So all these precautions are normally taken just to avoid dust. Dust plays very, very important role as far as product establishment and product continuity. This is not that we will be doing it for the first time. We don't need success for the first time in VCM. The success has to be continuous. And second thing is this process cannot be operator dependent. This process has to be automated. So in case if you are looking for something like that, you need to have some preconditions has to be done if you are planning to have a VCM. This is the cooling section, a special cooling section which will have air cooling as well as water cooling as well as air cooling depending on the type of film that we will be applying on the substrate. So that's it from my side for VCM, PVC, PET, PET plus PVC. And I think it's predominantly the need of the manufacturers or the technology providers as well as manufacturers to form a consortium and to have this as a manufacturing in India at this point in time. Having said that, I just present to you a case too. As we discussed a lot about PPGI, PPGI is pre-painted as well as vinyl coated metals. We also discussed since morning about the GI as well as GL, right? But now as we are moving towards zinc and magnesium alloy coating lines, right? So before I move on, I would also like to present to you a small a furnace which is around 500 tons TPA production which we are working with one of our customers for manufacturing GI, GIGL as well as ZNMG. So everything in one furnace. I like to keep this case today and I like to talk on this case during our next GCP meet or CC meet. Until then, thank you very much and thanks for patiently listening to me. Thank you.